Well, hello friends. Welcome back to the program. Today we are going to work on Assistant, which is the new information lookup mechanism in the system. And if we press super space, we are presented with this interface, which allows us to start asking for things from the system. And it looks up in a couple of different places. So the installed applications, but also searches the file system, and it also has a built-in calculator, which actually uses JavaScript, so you can do crazy things like that. I think one of the things that annoys me a little bit about the assistant is that it takes a moment to get the file system results, and I think we could do better. So today, I think we're just gonna profile it when I do a simple file system query and see what it's doing and see if we can do something a bit smarter and a bit faster. So let's get a profile of Assistant, and then I will simply type stdio, wait for results, and then kill it. And that gives us a perf core, which we can then investigate. Okay, so there are two chunks of time here. So the first thing we see is building the file system index. Assistant does that when it starts up. And we definitely spend some amount of time doing that. It looks like about half a second. And then this here is sort of continuously giving results as I'm typing stdio, right? And Assistant is already smart enough to abort current queries while you're typing. So if you keep typing, it will, even if the previous query didn't finish yet, it will cancel that and start a new one as soon as it realizes that you typed more. But let's see what it's doing. So we have two threads here, as we can see, two separate entry points, and most of the time is on the second thread. So let's do a top view so we can see what's going on in that thread. And in the background thread, we are doing a query into the file provider and creating a bunch of these file results. And here's the fuzzy match, which runs against everything in the cache of the file system. So already we can see here that we're making substrings when we can probably do substring view, for example. Maybe we can avoid creating lowercase strings. So some opportunities there. And then the file result constructor is calling GUI icon default icon a lot, or at least it's very heavy because because it's loading a PNG. I see. Okay, so that's probably going to be our first thing that we do. So if you look here, when I type stdio, all of these file system results have an icon, and all of them are the folder icon. So file provider, wait, how do I, no, not file icon provider, file provider. Here we are. So file provider, query. Let's see. So what this does is it will build a file system cache if needed. So this thing actually doesn't do anything if we already have a cache. So once you have a file system cache, we'll just keep that. But then it will cancel any ongoing fuzzy match worker and then start a new one. And then for every path in the full path cache, we'll run a fuzzy match against it, check if the score is good enough, and if so, we will append it to the results. And the file result constructor calls GUI icon default icon. Okay, so this is definitely costly, because this will just reload the PNG from disk every time. So what we could do here is simply cache this icon, and we would probably immediately see a huge reduction in work. Although now that I think about that, that's probably not the nicest feature, because I don't want every file to have the folder icon. Like what if I'm looking at studio.h, which is a C header file, right? So I would want that to have a C header file icon if there is such a thing. So what we should really be doing is using the file icon provider thingy from libgui. Let's see. But this also makes me wonder. This makes me wonder if we are here, we are looking through the entire full path cache and matching everything against it. But when it comes to the GUI, we only show like the top 10 results or whatever, or however many are on screen. So yeah, it's like not very many. 6 results. Oh, he's running very hot. Yeah, so I think we can definitely, we can do something smarter here. Like we shouldn't have to like fetch an icon for every possible result. Because if you type like A and you have 1,000 matches in the file system for A, but we're only going to show 10 of them on screen or however many, we should only go and look up 10 icons at most. So what if we, instead of this, we were to make the icon mechanism lazy so that the GUI will ask these result objects for the icon, and then at that point do we go and figure out what it should be. So I think we'll do that. So result. The assistant result class represents a single result from a provider. So the basic architecture is that the application has a set of providers: the file provider, app provider, calculator provider, and whatever else, terminal provider, URL provider. So a bunch of different providers. And then you query all the providers, and then they give you 1 or 0 or more result objects. And then those results are what you see in the UI. And at the moment, result has a bitmap that is passed to the result constructor and then stored with the result. But I think let's just not do that. And we will not pass a bitmap to the constructor. But instead, we will make the bitmap thingy virtual, and by default, it will return no bitmap, let's say. Yes, and then we can override this in every result now. So everybody has to figure out their own thing. For simplicity though, like we can just make them members in the existing result classes. So bitmap. Something like that. Oh, I should probably say override. Okay, and move bitmap. Yeah, let's do this for the existing ones. Can mark that as final. Yeah, that feels reasonable. So let's do that to the others. Calculator result. This thing could probably use a cache since it uses the same exact icon every time. But let's get clever later. Let's just do this for now. Don't have to get clever just yet. File result. Ooh, there we go, the file result. Okay, so that's the one that we're interested in. So we want to have a virtual bitmap thing. I can't type today, but we'll put this out of line so that it can do something. And I think we'll just do like a file system, file icon provider lookup in this virtual. That's gonna be nice. Okay, sure, more of these. Yeah, I need to copy paste a bit more. Oh, maybe I could have just done that actually. Yeah. Yeah, I can do it in the initializer list. Why not? Okie dokie, we are almost there. Yeah. This feels okay. And then the file provider. Now we need to implement that bitmap getter. So my thinking now is that the UI is probably not going to ask for file result bitmap on very many file results, only the ones that we see on screen. I'm assuming. We'll see. So what do we do here? We like return the GUI file icon provider icon for path for my title. I think the title of the result, does that not work? Oh, I have to say like bitmap for size 16. Yeah. Okay, so now we have header file icons. That's good. It still feels kind of slow. Studio. I mean, actually, it's definitely faster. It's just the first query, I guess, is a bit slower because we're waiting for it to load the file system. So on a fresh launch, we want to look for Flappy. The famous Flappy bug. Yeah. So let's quantify that this is actually faster. So let's see, profile. Assistant, Studio. I mean, it definitely feels faster, but I still want to check here. So Perf Core 46. This is me typing here. And actually, let's compare this with the Perf Core 33 that we had. So here is me typing Studio in the previous version. Oh shoot! But it's using the symbolication is all screwed up because it's like using old addresses. Though the previous profile doesn't record like which symbol is which address, so now it's all jumbled. So we can't really look at it that way, but let's see what it's doing at least. We have a sleep here in the background thread. It's funny. So fuzzy match, so like the file, the icon lookup is completely gone from the background thread. That's awesome. So now instead, in the background thread, we're seeing fuzzy match recursive is sort of what's taking time there. Actually kind of dominating the runtime, which is good, I think. So it means that we can probably improve that. And then what are we doing on the main thread? Where is the main thread? Start. Not too much happening on the main thread, actually. Let's go in main here. Okay, so we're doing a bit of, oh, here are the bitmap lookups. Okay, yeah, so originally the bitmap lookups were like 60-something%, right? 65% of runtime across 2 threads, and now we are below 3% of runtime across 2 threads. So we've effectively like gotten rid of that bottleneck, and now the fuzzy matcher is the thing taking time instead. So that is very, very good. Yeah, so I think we can be happy with that and just like commit this change, and then look at what improvements we could make to the fuzzy matcher to see if we can shave some time off of that. And actually, I guess something that we could do, just for reference, I was gonna say we could like log how long it takes to do the match, but this is obviously a good change. So let's not get bogged down in measuring since it's so obviously good. Assistant. Yeah, so make the, or you know what? I don't want to do 2 things in one commit. So here, what was the bitmap we were using previously? It was the file type folder, right? So we will use that first in the first commit. Assistant make result bitmaps lazy, or virtual/lazy result classes now return their bitmap via a virtual GFX bitmap getter. This can be used to do lazy. This effectively makes bitmap fetching lazy for file provider, or actually it makes it lazier, since only results that end up on screen actually get queried for their bitmap. Get asked for their bitmap, let's say. Yes. Let's see. This drastically reduces the amount of work done by the file provider query thread, or background worker. Cool. And then let's just do that thing again where we do the file icon provider. So assistant use file icon provider for file provider query results. Instead of showing the default folder icon for all file results, we now show an appropriate icon for the given file. Yeah, that's pretty nice. All right, so let's look at that fuzzy match function. Fuzzy match. What does it do? It calls fuzzy match recursive, presumably puts all the matches into here. Okay, so what was it actually doing that was slow? Because, I mean, obviously, fuzzy matching against all the possible paths in the file system is going to take a bit of time, but maybe it doesn't have to take as much time as we currently spend. Let's find out what we're actually spending that time on. So let's see, here would be our search. Fuzzy match, yeah, right. So we have string substring 8% here. Okay, so substring is quite heavy. If we turn this into a top view, what do we get? String substring is 38.79%. Yeah, right. So this is very, very substring heavy, and I think we can avoid that completely, hopefully. So what are we doing here? If needle substring 2 lowercase equals haystack substring 2 lowercase. Yeah, so there's definitely a way to avoid these, because we're just like creating a temporary substring, making it lowercase, and then comparing that against another temporary substring that we've made lowercase. We have substrings here. So what can we do? Maybe let's see if we can use substring view here. So that creates a string view without allocating. Do we have equals ignoring case? Probably exactly what we want, since that seems to be what's going on here, turning both into lowercase and comparing them. So equals ignoring case, haystack substring view, haystack index 1. Okay. And let's look at the other instances of substring down here. So current character and neighbor character. What's going on here? So again, getting a substring of a single character. We can definitely do that differently, like just with the bracket operator, I guess. And neighbor character, again, bracket operator, just to get the single character out. And then instead of .to uppercase, it would simply be, what are those things called? Character types. Let's see, to uppercase. To ASCII uppercase, that's right. To ASCII lowercase on the second one, sure. What don't you like here? Oh, one is U32. Oh, well. Let's go ahead and say that these are U8. Or why not U32 for that matter? And then we do this, since these are no longer strings. And let's see if it worked. It seems to work. Seems to work quite well, actually. So let's profile that. I mean, that's so much faster than when we started. So let's take a look at what he's doing now in this thread. We obviously don't have any substring at all anymore. So what is the background thread actually doing? This is the initial file system cache buildup job. This is 74% of the runtime. Oh, wait, look here. This is me typing. It's like actually nothing. Or it looks like almost nothing. That's fantastic. Okay, so what's going on here? fuzzy match, 33%, sure. Substring view. So we're still spending a little bit of time in substring view, which could probably be inlined, actually. I don't know why that's out of line. Equals ignoring case. I'm okay with that being out of line, but substring view, I don't know why my keyboard keeps switching to Swedish mode today. Substring view has a bunch of checks. Yeah, so maybe we don't want to inline it because of all the checks. I don't know. Anyways, it's so much faster now. Like, I actually feel like while I'm typing here, if I just let the initial indexing finish, then yeah. That's really cool. Cat, dog. Look at that. It's cat dog. I haven't looked at the cat dog for a while. Let's bring up cat dog. Hello, cat dog. So this is pretty good. Pretty good. Oh, see the speech bubble goes off screen. That's a completely unrelated thing, so let's not get distracted by that. Instead, let's just commit these changes by just, I mean, these are very simple changes, right? Like we just, instead of creating substrings which allocate heap strings, we now simply make substring views which are not heap allocated. So that'll be good. Don't use string substring, or let's say use string view more in file provider background worker, or file provider fuzzy matcher. By not allocating new string objects, the fuzzy matcher becomes a lot faster and more responsive while typing. Pretty good, pretty good. So now it's like the initial indexing time is sort of starts to become a bit more irritating. Like now I'm waiting and then I get the result. Because once it's indexed, it's not as bad. But that initial wait there, like stdio, choof. Let's see what we can do about that. So file provider build file system cache has a work queue, which is a queue of string, and it creates a background action which iterates as long as there are work items in the queue. It will pick one and create a directory iterator for that item, iterate the directory, stat everything in the directory, and then append full paths to the full path cache. Sure. And if anything is a link, like a symlink, then we just skip over it, which, you know, makes sense because we don't want to get trapped in sort of a recursion loop with symlinks. Right. Oh, and if something is a directory, then we push that onto the work queue so that this thing actually like incrementally discovers which directories need to be traversed. And you could turn this into a multi-threaded thing, I suppose, but it's not terribly important. I don't think our current system architecture would actually allow this to benefit that much. from being multi-threaded beyond like the 2 threads that we have now, because we have the main UI thread and the worker thread. I think that that's probably good enough for right now, but we can definitely do something here. So let's see what's taking up time here. It's Swedish keyboard again. Why? I don't know what's happening with that. Okie doke. Oh, wait, I do know what's happening with that. Oh, super space. So super space in Serenity is bring up assistant. Super space on my host machine is switch between English and Swedish keyboard. That makes perfect sense now. Okay. I gotta be aware of that. So let's get the profile of assistant starting up. Studio, Kluk, okay. And then we will look at it under the microscope here. So just the startup sequence and what we do here in the background thread. So build file system cache, totally dominated by lstat. And then dear iterator, it's like doing a little bit of stuff. But lstat calls into the kernel, and then the kernel does lookup metadata. So stat calls VFS lookup metadata for the path. And then 65% of all runtime is spent in path resolution. So I think we can improve this. So the issue is that we keep throwing these long absolute paths at the stat syscall or the lstat syscall, and then the kernel has to resolve the absolute path, right? Because that's what we keep giving it. If we were to instead give it relative paths and a starting location, then the kernel could probably go a lot faster because it would only have to like resolve one level of the directory hierarchy. So that's a technique that we've used in a couple of other places. So I think that will fit here. But the first thing that I'm going to do though is just time this, just to see how long we're actually spending on this. And that will also allow us to quickly spot if this is an improvement, because I'm not completely sure, but I feel like this should help. Built cache in milliseconds. Timer elapsed. All right. Okay, so Kluk. 667 milliseconds. 467. 460. Okay, so right after boot, the kernel file system cache is cold, right? So you get kind of a slower time from indexing the whole system, and then it gets a bit faster. So when cold cache, about 667, hot cache about 460, something. So let's see. So what we would want to do here is that we don't want to use lstat, but rather we want to use fstat@. And then you have to provide a file descriptor to start from, but we have the iterator. We have the directory iterator, so we can just use the file descriptor that thing uses to iterate. And then you pass in the is it no follow symlink or something like that. I think it's in facultal.h. At symlink no follow. Okay, there we go. Right, so now this thing will expect path to be a relative path starting at the current directory. So instead of asking for the next full path from the directory iterator, which gives us absolute paths, we will just ask for next path. which will give us just a file name of the next thing in this directory. And let's see, we'll call this base. Base directory, and then we want to iterate dot after we shadir to it. Does that work? Or maybe we don't even need to shadir, actually. We don't need to do that. We can just, we open a directory for the base directory, and then we do relative lookups using path. And for the full path cache, we still want to have a full path. So can we use a lexical path for this maybe? Lexical path join base directory, comma, path. Does that work? Let's see what this actually gives us. I forget how that works. Lexical path join. I think it does what I think it does. Full path. Okay, so we're missing the leading slash here from these. Wait, what does that mean? Can we just do this? I don't want to create a bunch of temporary strings at every iteration though, but so we're only going one level. Oh, because we have to put the full path into the work queue if it's a directory. Sure, that's fine. String like that. Okay, so now it finds everything. That's good. That's good. But then let's not log it. Okay, so 503 cold, 311 cold, hot, 323 hot. Okay, yeah, so it's like significantly faster caching while hot. And then we can also avoid creating a string here. So I'll just be a little cheesy and do something like this. You know, no big deal. Just to avoid that malloc and free for every step. 507 cold, 327 hot, 304 hot, 303 hot. These are pretty good numbers. So let's see what it looks like now if you profile it. Okay. So what you doing on the background thread? fstat at 60% in fstat at. Sure, that's fine. Systat, lookup metadata 50%. Yeah, so we're still seeing all the time spent in, or actually like half the time spent in path resolution, but now at least it's significantly faster because we don't have to start from the root every time. And path resolution in the kernel could definitely be a lot faster. It does a whole bunch of allocation that it could probably avoid. So there's a lot of room for caching and things like that. But that's sort of outside of the scope of what we're doing here. At least now we've done what we can from user space, which is to switch from absolute path lookups to relative path lookups. And that was made it a bit faster to build a cache. So that's good. Let's see if we can commit that. So let's get rid of the timer. Or I was just thinking, maybe that timer is actually nice. Like, since it's only once per launch of Assistant, maybe it's nice if we show how long it took to build a cache. Because if somebody sees a huge number when they run this on their local machine, then they can maybe investigate that and see if they can improve it. So Assistant, use relative fstat at lookups while building file cache. Fstat at while building file provider path cache. Fstat at allows the kernel to do relative path resolution instead, as opposed to absolute path resolution, which is significantly faster and allows us to build the path cache sooner. Yes. Okay. So I think these are some pretty nice improvements. So we've made the initial FS cache faster, and then we've also made the fuzzy matcher faster so that it's like a bit more responsive while you're typing. I think that's good. And obviously there's room for improvement here. I didn't investigate the fuzzy matcher algorithmically at all because I know that Spencer, who added it, wants to look into that anyway. And I'm sure that there's more stuff that can be done, but even by just taking like a sort of a superficial approach of going in with a profiler and saying like, oh, well, this thing and that thing is what's taking up or dominating the runtime, we were able to get some pretty solid improvements, even without like building a deeper understanding of what all the code is doing. So very, very nice. So I think that's going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out. I hope that you saw something interesting here. And this is, I think, one of my favorite types of video to make, just profiling stuff and making it faster. And this time I went in to work on something that I didn't really spend any time on personally writing this code before. So it was fun to go into something that somebody else wrote and profile that. So yeah, I hope you enjoyed the video, and I will see you all next time. Bye.